Hello and welcome. Today we're going to be discussing the process of reducing rational expressions. Basically, we're going to be reducing fractions that contain polynomials. First, let's recall basic reduction of fractions. In order to reduce a fraction, you must identify a common factor between the numerator and the denominator. So in the first fraction here, 15 over 12, I know that both 15 and 12 are divisible by 3 because 3 is a common factor. So what I'm going to do is I'm going to first rewrite this as 5 times 3 on top over 4 times 3 on the bottom. Now that we see those 3's repeated on top and bottom, I may cross them out. They simply form a factor of 1 together. And what I am left with is 5 over 4. To the right, I know that both 30 and 18 are divisible by 6. So I'm going to rewrite 30 as 5 times 6 and rewrite my 18 as 3 times 6. I cross out those 6's because again they are a common factor and together they form 1. And what I am left with is 5 on top and 3 for my denominator. Lastly, I know that both 27 and 45 are at least divisible by 3. Let's start with that and then identify a common factor later. So I can rewrite my 27 as 9 times 3 over 15 times 3. Well, if you notice, 9 and 15 can be factored further by a common factor of 3. So I'm going to write 9 as 3 times 3, and I still have another 3 after. 15 I can rewrite as 5 times 3, and I still have another 3 following. So now I'm going to cross out both 3's that repeat, leaving me with a 3 in my numerator and 5 in my denominator. So in this case, I was able to cancel out more than simply one factor. Down on the left, we're going to repeat this process similarly, except we're going to introduce variables as well. On the top, I see 10, which can be rewritten as 5 times 2, and x to the third is x times x, since it's x to the third power. On the bottom, 25 is 5 times 5, and I simply have x to the second, or x times x. I see a common factor of 5 between the numerator and the denominator, so I'm going to cancel this out. I also see an x repeated on numerator and denominator, as well as a second x, so I cross both of these out. On the top, I'm left with a 2 and an x, so that's simply 2x, and on the bottom, I only have a 5. You may also recall our subtraction of exponents when we have the same base in the top and the bottom of a fraction. Since I have the same base of x, I have an exponent of 3 on top while I have an exponent of 2 on the bottom, I may simply subtract the 2, leaving me with only x to the first on the top. For my 12 and 16, I know that 12 and 16 have a common factor of 4, so I rewrite my 12 as 3 times 4. I'm going to use my subtraction of exponents to simplify, so I'm not going to write out all 4 of those x's here. The 16 is 4 times 4, and again I'm just going to leave this as x to the 5th power. So I can cross out my 4's that are repeated, and since I'm multiplying by 2 bases that are the same on the top and the bottom, I'm simply going to subtract those exponents. When I do so, all of the x's from the top go away, and I'm left with only one x on the bottom. So on the top of my fraction, everything went away except for this 3. So I'm left with just a 3 in my numerator, and on the denominator I have a 4 and an x, so just 4x. Last, I'm going to notice that my 21 and 49 are both divisible by 7. So I may rewrite 21 as 3 times 7, and I'll leave my x to the 7th with its exponent. 49 can be rewritten as 7 times 7, and again I'll leave my x to the third with its exponent. I cross out that common factor of 7 and subtract the exponents on my x's. What I'm left with, all of my x's cancel on the bottom, and on the top I have x to the 4th power, because 7 minus 3 is 4. So in my numerator I now have 3x to the 4th. In the denominator, everything canceled except for a 7. Now we're going to take this into a more advanced type of reducing rational expressions. When you see this first expression that I've given you, your initial thought might be, let's cross out the 2's, leaving me with x over 7x. And maybe, since you see an x in the numerator and in the denominator, you might want to cross those out. However, there's a problem. Our problem is that we are not allowed to reduce over addition. This plus sign right here tells us that we are not, in fact, allowed to cancel out those 2's. You may only reduce over multiplication, canceling out entire factors of a polynomial. So if you see below, I have x times this entire factor of x plus 2, and y times this entire factor of x plus 2. Now, since this x plus 2 is being multiplied, we can cross out that entire factor with the entire factor in the denominator. Now, I'm left with x in the numerator and only y in the denominator. From here, I cannot simplify any further, so this is the most reduced form of my original expression. Now we're going to reduce each of the following completely, just as we did on the previous slide. What we are going to do is look for identical common factors between the numerator and the denominator. Now, if you notice, each of these has been factored completely for you. Both the numerator and the denominator cannot be factored any further. So all we are going to do is look for identical factors between the top and the bottom of each fraction. So for this first one, I see an x minus 4 repeated on the top and the bottom, so I can cancel out that entire factor. Now be careful, this is not the same as simply only crossing out the x's because the x's are repeated. We may only cross out that whole factor or nothing at all. So I cross out all of the x minus 4, and what I'm left with on top is an x plus 3, and on bottom I have an x plus 5. To the right, I see an x minus 5 repeated, and again I'm crossing out that entire factor, not just the x's or the minus 5's. The next factor, I have a plus 1 on top, while the bottom contains a minus 1, so I cannot reduce either of these. So what I'm left with is simply x plus 1 over x minus 1, and there's nothing more you can do to reduce. Remember, you may not cross out those x's because they are attached to the addition and subtraction. Down below to the left, first thing I'm going to look at is the 8 and the 16. 8 and 16 are both divisible by 8, so I reduce my 8 to a 1 and my 16 to a 2. Then I look for any other common factors between the numerator and the denominator. I see this entire 2x minus 1 repeated with the middle factor on the bottom. I also see an x plus 3 repeated. You may either cross out one of the x plus 3's or the other. You may not cross out both. I'm going to choose the first one. So what that leaves me with is a 1 times 4x plus 3 on the top, or just 4x plus 3. And on the bottom, I have a 2 and my other factor of x plus 3. From here, I'm going to distribute my 2 to simplify completely, and I'm left with 4x plus 3 in my numerator, and my denominator, after distributing that 2, is now 2x plus 6. You may not reduce any of the factors any further, so this is the most reduced form of our original expression. To the right, I'm going to reduce the 10 and the 25 both by 5, leaving me with a 2 on top and a 5 on bottom. I do not see any 2x minus 3's on the bottom. I see a 2x minus 1, but since that does not match the entire 2x minus 3 above, I can't do anything with it. This 3x plus 1 matches the 3x plus 1 on the bottom, so I can cancel those out. And x plus 2 does not match anything on the bottom, so I may not cancel it. So what I'm left with on the top is a 2, and then I have a 2x minus 3, and another factor of x plus 2. On the bottom, I have a 5, I have a 2x minus 1, and an x plus 5. From here, you should distribute your 2 and distribute the 5 on the bottom, leaving you with one factor of 4x minus 6, and that x plus 2 is still the same. And on the bottom, distributing that 5 leaves me with a 10x minus 5 and an x plus 5. Now from here, of course, we must multiply both the numerator and the denominator out completely. After FOILing, distributing my 4x and then my negative 6, your numerator should be 4x squared plus 2x minus 12, while your denominator, again distributing your first term, which is now 10x, and then distributing your negative 1, your denominator should consist of 10x squared plus 49x minus 5. I'll let you do that FOIL process on your own. Go ahead and pause the video and try the next 4 on your own. Remember to simplify completely. For your first, you should have crossed out the x minus 1's, leaving you with x plus 6 over x minus 3. Second, cross out the x minus 2's, leaving you with x minus 3 over x minus 5. Third, down to the left, the only thing that could reduce were your coefficients and the factors of 5x plus 1. After doing so, I was left with this rational expression. I then simplified by FOILing completely, leaving me with the resulting expression. And last, I was left with 3x minus 6 over 2x plus 6. On our next slide, we're going to reduce each of the following rational expressions completely again. However, first, we must factor each polynomial completely. So remember your rules of factoring. Step 1 is always your greatest common factor. So first I'm going to take out the greatest common factor of both my numerator and the denominator. If I can factor further, then I will. I factor out an x from the top, leaving me with x plus 3. On the bottom, I take out a 5, leaving me with x plus 3. I can't factor further, so now I cross out the repeated factors and see what I'm left with is the x for my numerator and 5 for my denominator. To the right, I take out the GCF of 2x squared, leaving me with 4x plus 3. And in the denominator, I factor out a 6, leaving me with 4x plus 3. I see I can cross out the 4x plus 3's, but I may also reduce my 2 and my 6. 2 becomes a 1, my 6 becomes a 3. So in my numerator, I'm left with just 1x squared, and my denominator, just a 3. Go ahead and try the next 2 on your own after pausing the video. Go ahead and quickly check your answers by pausing the video, and then we'll go ahead and move on. In this next slide, we're going to again factor completely so we may reduce completely. However, now we're going to deal with trinomials. So we're going to have to use our diamond method to factor. Again, we always look for the greatest common factor, but in this first one, you'll see there is none in the numerator. So I proceed to use my diamond method to factor. When you do so, and I won't go through that process with you, you should get 2k minus 1 as your first factor, and just k minus 1 as a second factor. In the denominator, I see a GCF of 2k squared that I will factor out, leaving me with k minus 1. Now that everything is factored, I look for entire factors that are repeated. These k minus 1's can be reduced, leaving me with just 2k minus 1 in the numerator and 2k squared in the denominator. Go ahead and pause the video and try the next 3 on your own before we proceed to the last slide. Go ahead and check your answers after pausing the video, and we'll go ahead and move on to the next slide. Here we are going to reduce just as we did in the previous slide. However, now both the numerator and the denominator are trinomials, so you must use the diamond method on both of those polynomials. I'll go ahead and let you practice these 4 on your own. So thank you so much for watching, and I hope you enjoy the rest of your day.